Hello, and welcome to Calculus Lesson 16. Today we are going to cover logarithms of products and quotients, logarithms of powers, and exponential equations. It's all about logs today. Now, I love logs because they reflect, let's see if I can talk and write at the same time. They reflect who God is. Now, you might look at that and be like, what in the world are you talking about? Well, what a log does is it basically takes this really big set of data and shrinks it into something that we can understand, right? So it undoes an exponential. And so oftentimes when we're graphing really big things, like population numbers or, I don't know, spread of a virus that is in the 10 to the whatever power, we'll put it on a logarithmic scale so we can see everything that's happening over the short term, right? The early numbers, 1 to 10, 10 to 100, and then 100 to 1,000, 1,000 to a million, or 10,000, and from there. And so it shrinks the further end of the scale closer. And I think it's so cool because I'm reminded how often we look at things through our finite, shrunken view of God, right? All the things that we can perceive and understand, when really there is so much more to God than we could ever fathom or see. On this lesson, we're going to look at the rules of logs. So remember, if you add two logs, you multiply the arguments or the numbers inside. If you subtract them, you divide the arguments. And finally, if you have a number in front, that just goes up as a power. Simple stuff from pre-calc. Hopefully you remember that. Next, let's solve some logarithmic, there we go, we got it, equations. Now, there's two types. There's one type where you have logs on both sides, like this one. This is the easier one. Okay, I have logs over here, I have logs over here. Remember, ln is log base e. I can combine these. Since it's subtraction, I will divide. And I have ln of something equals ln of something, so I'll set those two somethings equal because ln is a one-to-one function. From here I can solve and I get x equals 29/13. This looks like it's negative. If I plug that back into the original, I find out that that's plugging in a negative to a log, and so this one in fact has no solution. Okay, you can never plug in negative values to a log or have the base that is negative, and that's because of its roots in exponents. Okay, let's try this one. Log base 4 of x plus 2 plus log base 4 of 5 equals 2. Now this one is a little bit trickier because we have logs on one side, which I can combine by multiplying, but it's equal to a number. It's not equal to a log over here. So in this case, I have to do base to the output, or 4 squared equals the input. So if I solve this, it looks like I get 6/5. Every time you do a log problem where you have a logarithmic equation, you have to plug that back in to make sure you're not plugging in a negative. In this case, we are not, and we are set. So let's solve some exponential equations now. Now, some of these are able to be solved without logarithms, and some of these require a logarithm. So we're going to solve 8 to the 3x plus 2 equals 16 without using logarithm. The key here is this. If both of these numbers can have the same base, then I can set the power equal and I'm done. In this case, 8 is 2 cubed to the 3x plus 2. And 16 is 2 to the 4th. So if I multiply these, I have 2 to the 9x plus 6 equals 2 to the 4th. And I can set 9x plus 6 equal to 4. That looks like x equals something. -2/9. Now, can I have a negative power? Absolutely. I just can't have the base be negative. I most likely will not get a negative number out. So this is totally valid. You can only not plug in negatives to logarithms. I'm going to sneeze. Watermelon. All right, we're good. Moving on. Let's try this problem. Unfortunately, on this one, we can't get the same base. So we have 10, so the negative 2x plus 2 equals 8. There's no real good way to get 10 and 8 to have the same base. It's not like 8 and 16 where they'll have 2 in common. So here, I'm going to either take a log or an ln of both sides. It makes sense to take a log because log of 10 will cancel because log is log base 10. So I'm going to take log of both sides. If I had an e in my problem, I would use ln. If I had neither 10 nor e, I would use ln because it's one less letter to write each time. So if I do this, remember that I can take this down as a power. And log of 10, remember there's an invisible log base 10 of 10. That equals 1. Since this is multiplication, it's gone. And I have negative 2x plus 2 equals log of 8. X equals log of 8. Sorry, 2 minus log of 8 over 2. Ugly? Yeah. Is it like impossible? No. And so that, my friends, is problem set 16.